students, I hope all of you are doing good. Let's start today's chapter, playing with numbers. In this chapter, we're going to learn about these topics. Okay, introduction. We learned in our previous class about concept of factors, multiples, prime numbers and composite numbers with their properties. In this chapter, we will enhance our knowledge up to natural numbers. First, we'll talk about factors and multiples. Factors. If we have to write a given number as a product of two numbers, let us see how many possible ways are there. Let the number is 44, 42. One way is 42 into 1 or 42 is equals to 1 into 42. Is it the only way to write it? Of course not. It can be written in many ways. 42 is equals to 2 into 21 or 21 into 2, or you can say 3 into 14 or 14 into 3 or 6 into 7 or 7 into 6. This fact can be made use of in practical situations as well. Suppose we have 42 bananas and we want to distribute these to our friends, then the different possibilities are we give all bananas to one friend, that is 1 into 42, or we divide them equally among two of our friends, then each will get 21 bananas, that is 2 into 21. Or we may divide them equally among 3 of our friends, that is 3 into 14, so that each will get 14 bananas. Okay. We may divide them equally among 6 of our friends, so that each one will get 7 bananas, that is 6 into 7. These situations can be reversed also. Thus, we may give 1 banana each to our 42 friends, so that 42 is equals to 42 into 1 or 2 bananas to each of our 20 friends, that is 42 is equals to 21 into 2 or 3 bananas to each of our 14 friends, that is 14 into 3. Okay. Also, we can give 7 bananas to each of our 6 friends, that is 42 is equals to 7 into 6. From the above example, it is clear that 42 is exactly divisible by these numbers, which are these 1, 2, 3, 6, 7, 14 and 21 and 42. These are all called factors of 42. Thus, we can say that a factor is an exact divisor of a number. A factor of a number is that which divides the given number exactly with 0 remainder. Let us write the factors of some of our natural numbers. Okay. So, factors of 4 are 1, 2, 4. It has 3 factors. 5, it has 2 factors, and 6, 1, 2, 3, 6, it has 4 factors. Okay. No more. For all natural numbers, 1 and number itself are always it's a factor, but if we exclude these two numbers, that is 1 and the number itself, then the remaining factors are called proper factors. Example factors of 18 are 1, 2, 3, 6 and 9, 18, and proper factors of 18 are 2, 3, 6, 9. B. Proper factors of any number lie between 1 and the number. And C. For prime numbers like 29, factors are 1 and 29, but there is no proper factor for prime number. Okay. So, from the above example, we find that 1 is a factor of each natural number. Right. Example 4 into 5 is equals to 4. 5 into 1 is equals to 5. Every natural number is a factor of itself. Example 8 is equals to 8 into 1 and 9 is equals to 9 into 1. Every factor of a natural number is less than or equal to that number. Every natural number has a finite number of factors. Remember that. Whatever number it is, it will always have finite number of factors. Okay. It is important to remember that 0 is not a factor of any natural number, as 0 into a is equals to 0, okay, which you already know that whenever we multiply a number by 0, the product is 0. Where here a is any natural number and division by 0 is not possible. Multiples. As we have seen, a factor is an exact divisor of the number. Thus, 2, 3, 6, 7, 14 and 21 are all factors of 42. Then 42 is called multiple of these numbers of factors, right? Even and odd numbers. I am sure all of you know what are even numbers and what are odd numbers. Okay, let's recall. Natural numbers can be divided into two groups called even and odd. Even natural numbers. A natural number is called even if it is exactly divisible by 2. That is, if 2 is a factor of it. This 2, 4, 6, 8, 10, 12, etc. are all examples of even natural numbers. Odd numbers. A natural number is called odd if 2 is not a factor of it. That is, it is not divisible by 2 exactly. Thus, 1, 3, 5, 7, 9, 11, etc. are all examples of odd numbers. Thus, all the numbers ending in 0, 2, 4, 6, 8 are even, and those ending in 1, 3, 5, 7, 9 are odd numbers. For example, 3 and 7 are factors of 21. Thus, 21 is a multiple of 3 and 7. A multiple of any natural number is obtained by multiplying that number by any other natural number. Remember that, except 1 and the number itself, rest all factors are called proper factors, as I told you earlier. Okay, and multiple of a number is always greater than or equal to that number. A given natural number can have infinite multiples. Okay, every number is a multiple of itself, and every natural number is always a multiple of 0 is neither even nor odd number. Okay, let's do example 1. You have to find out the factor of the following numbers. So first is a 64. Okay, one method is given to you that you can write like 1 into 64, 2 into 32, and 4 into 16, 8 into 16. Okay, so the factors are 1, 2, 4, 8, 16, 32 and 64. Alternatively, what you can do is you can divide by 1. 64, then you will divide this number by 2, you will get 32. If you divide it by 3, it will not be completely divisible. So we will skip that number. Then divide by 4. You will get 16. 5, of course not, because there is no 0 and 5 at units place. So 64 cannot be divided by 5 completely. Okay, then we'll skip 5, we'll skip 6 also, 7 also, then we'll divide it by 8. Okay, so these are the factors. 1, 2, 4, 8. Okay, 8 already written, 16, 32, 64, right? Similarly, you will find out the factors of 121 and 144. Example 2, in this example, you have to find out the multiples of 5, 8 and 12. Okay, so you will multiply 5 by first 1, then 2, then 3, then 4, then 5, because you have to find 5 multiples. Okay. Now, prime and composite numbers. Prime numbers. A prime number is a natural number having only 2 factors, namely 1 and the number itself. This one is not a prime number as it has only 1 factor. For example, 2, 3, 5, 7, 11, 13 are all prime numbers. Number 2, composite numbers. A natural number having at least 3 factors is known as composite number. This 4, 6, 9, 12, 10, 15, etc. all example of composite numbers, because factors of 4 are 1, 2, 4, factors of 10 are 1, 2, 5, 10, and factors of 8 are 1, 2, 4, 8. Okay. No more. It is important to note that 1 is neither a prime nor a composite number. So it is called a unique number. Okay. Number 2, twin primes. The prime numbers which differ by 2 are called twin primes. For example, 3, 5. If you find the difference of 3 and 5, you will get 2. If you find the difference between 7 and 5, you will get 2. So 5, 3, 7 or 5, 7 are twin prime numbers. Okay, 11, 13, 17, 19, 29, 31, these are also twin primes. Okay. Number 4, co-prime numbers. 2 numbers are said to be co-prime if they do not have any factors common other than 1. For example, 8 and 15. These 2 numbers have only one common factor, which is 1. 21 and 64, 2 and 9 and 5 is 7. Okay. Remember, co-prime numbers need not be prime. Okay, they can be both be prime, as in 5 and 7. Okay, 5 and 7 are co-prime numbers, right? And both are prime. B, they can be both composite, as in 8 and 15. 8 is a composite number and 15 is also a composite number. Okay, but these are co-prime numbers, right? C, they can be such that one is prime and the other is composite, as in 2 and 9. 2 is a prime, whereas 9 is composite, right? Number 5, perfect numbers. Okay, if the sum of all the factors of a number except the number itself is equal to the number, then that number is called perfect number. Okay, this is a new term for you. For example, factors of 6 are 1, 2, 3 and 6. Okay. Now what will we do? We will find the sum of these factors but except 6. So 1 plus 2 plus 3 is equals to 6. That means it is a perfect number, 6. Okay. 6 is a prime triplet. A set of 3 successive prime numbers differs by a is called prime triplet. For example, a 3, 5, 7 is the only prime triplet. Okay. Some important points about prime numbers. You should remember this, that 2 is the smallest prime number. 2 is the only prime number and other prime numbers are odd. Number 3, look at the following numbers. 5 is equals to 2 into 2 plus 1. 7 is equals to 2 into 3 is plus 1. 11 is equals to 2 into 5 plus 1. Similarly, 13 is equals to 2 into 3 plus 1 and 23 is equals to 2 into 11 plus 1 and so on. Now more, every odd prime number can be written as product of prime numbers plus 1. Okay. 4. There are some prime numbers which are obtained by interchange of the digits of some other prime numbers. For example, 13 and 31, both are prime numbers. 37 and 73. Okay. You should try to find out some more examples. Okay. Now, example 4. The numbers 13 and 31 are prime numbers. Both these numbers have same digit, 1 and 3. Find such pairs of prime numbers up to 100. Okay. So, first you will write down all the prime numbers between up to 100. Okay. Up to 100 you will write and then you will find these pairs of prime numbers. Right. To exercise 3.1, write down all factors of 256. Let's do it. So we have to find out the factors of 256. We'll divide it by 1, so we'll get 256. It is an even number, so 2 will divide this number completely. Okay, so what will you get? 128. Right? It cannot be divided by 3. Then we will divide it by 4. So what will you get? 64. Okay. Then there is no 0 and 5 at one's place, so it cannot be divided by 5. Now, by 6 also it will not be divisible completely. Okay. And 7, in case of 7 also, this number cannot be divided by 7 completely. So then we'll divide it by 8. 8 3s are 24 and 8 2s are 16, right? So now let's write down the factors, all the factors. You will go down first, 1, 2, 4, 8, then you will move upward, 32, 64, 128 and 256, right? Test of divisibility. We have learned about some tests of divisibility in earlier classes. These tests are shortcut to find out whether a given number, however large, is divisible by a given number or not, without actually performing the division. We revise these tests once again. Number 1, divisibility by 2. All even numbers are divisible by 2. You know that very well. Thus, if a number ends in 0, 2, 4, 6 or 8, it is always divisible by 2 as it is an even number. For example, all these numbers are divisible by 2. Number 2, divisibility by 4. If in a given number, the number formed by tens and once a digit is divisible by 4, then the whole number is divisible by 4. For example, you have given this number 408084 is divisible by 4. Okay, we will check only last 4 digits, last 2 digits actually, 84. So 84 is divisible by 4, that means the whole number is divisible by 4. Right. Also, this number is also divisible by 4, but this number is not divisible by 4 because last 2 digits make a 42, okay, which is not divisible by 4. Remember, a number ending in 2 zeros, okay, is always divisible by 4. For example, this number, it has 2 zeros at the end, so it will be divisible by 4, right? Number 3, divisibility by 8. A number is divisible by 8 if in the given number, the number formed by hundreds, tens and ones digit is divisible by 8. Thus, in this number, last 3 digits are 5, 6, 8 is divisible by 8, but this number is not divisible by 8. Also, this number is divisible by 8. Remember, a number of ending in 3 zeros is always divisible by 8. Okay. Number 4, divisibility by 5, which is very easy. If a number ends in 5 or 0, it is divisible by 5. For example, see this number ending is 5. In this number, 0 is at one's place. Okay. So, these are divisible by 5. But number like these and these are not divisible by 5. Right. Number 5, divisibility by 10. Again, this divisibility check is also very simple. All the numbers ending in 0 are divisible by 10. Thus, these two numbers are divisible by 10, whereas these numbers are not divisible by 10. Number 6, divisibility by 3. If the sum of the digits of a number is divisible by 3, the number is also divisible by 3. For example, let us take the number this 9, 8, 7, 6, 5. Let's add these digits 9 plus 8 plus 7 plus 6 plus 5. What will you get? 9 plus 8 is 17. 17 plus 17 is 24 plus 6, 30 plus 5, 35. Okay. Is 35 divisible by 3? No. 35 is not divisible by 3. So, this number is also not divisible by 3. Now, in this case, now the numbers are 3, 5, 7, 8, 2, 5. Now, let's do the sum of the digits. Find the sum of these digits. 3 plus 5 plus 7 plus 8 plus 2 plus 5. 3 plus 5, 8. 8 plus 7, 15. 15 plus 8, 23 plus 2, 25 plus 5, 30. Okay, so the sum of the digit is 30. 30 is divisible by 3. Therefore, this number is also divisible by 3. 7. Test of divisibility by 6. A number is divisible by 6 if it is divisible by 2 and 3 both. For example, 2106 is divisible by 6 because it is divisible by 2 and 3 both. Divisibility by 9. If the sum of the digits of a given number is divisible by 9, the number is also divisible by 9. For example, this number you have 9, 8, 8, 7, 6, 7. Let's do this sum of these digits. 9 plus 8 plus 8 plus 7 plus 6 plus 7 is equals to 45. So, 45 is divisible by 9. So, this number is also divisible by 9. But in the number which is a 4, 5, 2, 3, 6, 2, the sum of the digit is 4 plus 5 plus 2 plus 3 plus 6 plus 2 is equals to 22, which is not divisible by 9. So, this number is also not divisible by 9. Okay. So, the given number is not divisible by 9. Next, divisibility by 11. In a given number, if difference between the sum of the digits in the odd numbered places and the sum of the digits in even numbered places is either 0 or a multiple of 11, the number is divisible by 11. For example, consider the number. Okay, let's do it. Okay, so the number is 764 3251. 3251. Okay. See, sum of the digits in odd places. Odd and odd places. These numbers are at the odd places. 1 plus 2 plus 4 plus 7 is what? 7 plus 4, 11 plus 2, 13 plus 1, 14. Okay. Sum of odd places. Next, sum of even places. Sum of digits of even places is equals to, you have this 5 plus 3 plus 6 is equals to 14. Okay. Now, let's find the difference of these two numbers. What will be the difference? 0. Difference is 0. That means this number is divisible by 11. Okay. Now consider another number which is given there. So the sum of digits in odd places is a 2 plus 9 plus 7 plus 5 is equals to 23, and the sum of the digits in even places is 3 plus 6 plus 4 plus 8 is equals to 21. The difference of these sums is equals to 23 minus 21 is equals to 2. Since 2 is not a multiple of 11, so the number, that means this number is also not divisible by 11. Okay. Example 9, using divisibility test, determine which of the following numbers are divisible by 3, 4, 6, 8, 9, 10, 11. So you have to keep in the mind all the rules which I told you, and then you will find whether these numbers are divisible by these numbers or not. Okay. Properties of divisibility. Number 1, if a number is divisible by another number, it is also divisible by each of the factors of that number. For example, 135 is divisible by 15. Thus, 135 is divisible by all the factors of 15. The factors of 15 are 3 and 5. That means 135 is also divisible by 3 and 5. This property is called divisibility of factors. Number 2, if a number has 2 or more co-prime factors, then the number is divisible by the product of the co-prime factors. For example, 4 and 5 are co-prime and 140 is divisible by 4 as well as by 5. Thus, it is also divisible by the product, that is 4 into 5, that is 20. Consider the co-prime 8 and 9. Now, 288 is divisible by 8 as well as by 9. Thus, it is also divisible by 8 into 9 is equal to 72. To test if a number is divisible or not, to test if a number is prime or not, we need to test its divisibility by smaller prime numbers. If we have to find the largest prime number to be tested as a divisor, the procedure is clear from the example. So what does the example say? Find the largest prime number to test as a divisor to find if 131 is a prime number, and hence find whether 131 is prime or not. So what will you do? You will divide it first by 2, you will get the remainder, then you will divide it by 3, then you will get the remainder of 2, then you will divide it by 5. So we are dividing this number by a prime number only. Since the quotient 10 is less than 13, we stop and conclude that 13 is the largest prime number we should test. Since 131 is not divisible by any of the prime numbers up to 13, it is a prime number. Okay. Now let's do exercise 3.2. Question number 1. Test the divisibility of 2 by 2 of the following. You can do it easily, because all the even numbers are divisible by 2, right? Prime factorization. Factorization of a number means expressing it in terms of its factors. Consider a number 36. First method is 36 is equals to 1 into 36, but 36 is not a prime number. Then we'll further, what will we do? We will further divide it. 2 into 18 is a 36, okay. Then how can we divide 18? 2 into 3 into 3. Similarly, we can also write 36 is equals to 3 into 12, which means a 3 into 2 into 2 into 3, right? And one more method is there. 4 into 9 is 36. So we can write 4 as 2 into 2, and we can write 9 as 3 into 3, and 36 is also 6 into 6, which is equals to 2 into 3 into 2 into 3. So 36 is equals to 2 into 2 into 3 into 3. Thus 2 into 2 into 3 into 3 is a prime factorization of 36. Each factor of 36 is a prime number and is called prime factorization of 36. Every composite number has a prime factorization which is unique. Second method, we can also determine the prime factorization of a number, say 36, using a factor tree method, which you did in your earlier class also. Okay, 36, this is the factor tree method. 2 18s are 36, then 2 9s are 18, 3 3s are 9. So here these are the prime factors of 36. Okay, there are many methods. You can also write 3 into 12 is also 36, 6 into 6 is also 36, 4 into 9 is also 36. Okay, this prime factorization of 36 is this. Now, third method, using test of divisibility, we can determine the prime factorization of 36. 36 is a composite even number, so divisible by 2. Again, 18 is a composite even number divisible by 2. Again 9 is divisible by 3. At the end we get 3, which is a prime number. This prime factorization of 36 is this, which is again same. Okay, this is the third method. Okay, now example 11, prime factorization of 98 you have to find using factor tree method, which you already know how to find a prime factorization of any number using factor tree. Okay, remember, read question very carefully. If method's name is not given, you can use any method. Okay, B, if name of method is given like factor tree method or division method, then it is compulsory to use that method. Okay, highest common factor, that is HCF. Highest common factor is the greatest number which divides two or more numbers, leaving no remainder. There are two methods of finding HCF of two or more numbers. Number one is prime factorization. Number two is successive division. Right? No more. Another name of HCF is GCD, that is greatest common divisor. Okay, so GCD and HCF have same meaning. Right? Let's find out the HCF of 48, 72 and 144 using prime factorization. Okay, so first 48, 2 24s are 48, then 12, 2 6s are 12, 2 3s are 6 and 3 1s are 3. Okay, next we have a 72. 2 will start from 2 because it is an even number. 36, then 2, 18, 2, 9, 3 3s are 9 and 3 1s are 3. Okay. Similarly, we will find out prime factorization of 144 using this similar method. Okay. Now, let's see. 48 is equals to 2 into 2 into 2 into 2 into 3, right? And 72 is equals to 2 into 2 into 2 into 3 into 3, and 144 is equals to 2 into 2 into 2 into 2 into 3 into 3. Okay. So, HCF, here HCF, what would be? Product of common factors. Okay. And what are the common factors? Let us find out. Okay. 2. Okay, then again 2, then we have one more 2 common, and then 3. So 2 2s are 4, 4 2s are 8 and 8 3s are 24. So the HCF is 24. Okay, and example 15, in this case we have chosen the division method, successive division method. Okay. Remember, don't forget to read the name of method used in question, and it is a must to use that method. If no name is given, then you can use any method, right? Okay. So, how you will find HCF by this method? Step 1, divide the bigger number by the smaller number. The remainder is what? 385. Now, divide the first divisor, that is 935, by the remainder 385, because here, see, now in this case what happens? Remainder becomes a divisor, okay, and here it will become the new dividend. So continue this method until the remainder is 0. The least divisor is the HCF of given two numbers. Therefore 55, okay, is the HCF of 935 and 1320. The method of successive division is mainly used to find the HCF of large numbers, because method of prime factorization is too lengthy for large numbers. Okay, let's do this example. You have to find out the HCF of these two numbers, which are, what are the numbers? Let's have a look. You have this number 1320. This is the bigger number, so you will divide this number by the smaller number, which is 935. Okay. So, 935s are 935. 10 minus 5 is 5. Then 11 minus 3 is 8. And 12 minus 9 is 3. Okay. So, the remainder now becomes, now this remainder will become the divisor. and 935 is the dividend. Okay, 3852,770. 13 minus 7 is 6, 8 minus 7 is 1. Okay, now this remainder will become the divisor, and the new dividend is this, 385. 165 2s are 2, 5s are 10, 2 6 are 12, 1 13 plus 1, 2 1s are 2 plus 1, 330. Now this will become the new divisor, and this is the dividend. Now 155, 3s are 165. Now the remainder is 0, so the HCF is 55. Okay. Now lowest common multiple, that is LCM. The lowest common multiple of two or more numbers is the smallest number which is divisible by each of the given numbers. There are two methods of finding LCM. One is prime factorization and one is division method. Okay. Example 18, find the LCM of 15, 18 and 24 by prime factorization method. Okay. So first we will start by prime factorization method. Okay. Here what will we do? We will multiply the common factors once. Okay. And then we will multiply them with the other remaining factors. So here we will get answer 360. Example 19 is find the LCM of 48, 72 and 144 by division method. So what will you do? Step 1. Write the numbers as shown in the table. 48, 72 and 144. Okay. Like this. Step 2, divide all the numbers by a common factor which is prime, that should be prime. Okay. Step 3, write the quotient in case below the number, copy the number as which is not completely divisible by that prime factor. Step 4, continue this method of dividing prime factors till we get quotient 1 for each number. Step 5, multiply all prime factors which gives LCM of the given numbers. So let's start with 2. 2 24s and 48 and 36, 72. Again we will divide these numbers by 2. All are even numbers. Okay, 36. Then 2 6 are 12, 2 9s are 18 and 2 18s are 16. Now 2 3s are 6, but 9 cannot be completely divided by 2, so we will write it as it is, 9. Now we'll divide by 3. 1s 3, 3, 3, 1, 1, 1. Okay. Now we will multiply all these prime factors. Okay. So what will we get? We will get this answer, that is 144, right? Properties of HCF and LCM. Let us take two numbers, 49 and 14. HCF of 49 and 14 is equals to 7. LCM of 49 and 14 is equals to 98. So HCF into LCM of 49 and 14 is equals to 7 into 98, that is 686. Also, this shows that product of two numbers is equals to the product of their LCM. Okay. So what is the relationship between this? HCF into LCM is equals to product of two numbers. Okay. So this is the formula, product of two numbers is equals to product of their LCM and HCF. No more. Some important properties of LCM and HCF are as under. Number 1, HCF of two numbers is never greater than any of the two numbers. Number 2, LCM of two numbers is never less than any of the two numbers. 3, HCF of two co-prime numbers is always equals to 1. 4, LCM of two co-prime numbers is equals to product of the two numbers. Look at the following example. 9 and 14 are co-prime and their HCF is 1 and their LCM is 126. That is 9 into 14. Okay. Number 5, HCF of given numbers is always a factor of their LCM. For example, HCF of 15 and 20 is 5 and LCM of 15 and 20 is 60. And HCF 5 is a factor of LCM 60. Okay. Let's do an example. 21, the product of two numbers is 864 and their HCF is 12. Find the LCM. Okay. So we have this formula, product of two numbers is equals to HCF into LCM. Okay. So product is 864, HCF is 12. You have to find the LCM. So what will we do? we will divide the product of numbers by 12. Okay, 12 sevens are 84. Okay, 12 twos are 24. So 72 is the LCM, right? Let's do exercise 3.3. Number 1, find the prime factorization of the following by factor tree method. Here a student method is given, which is a factor tree method. Okay, so we have 75. 5 15s are 75, then 3 5s are 15. Okay, so 75 is equals to 3 into 5 into 5, right? So students, now you will do practice of this chapter and you will also do practice of the remaining questions also.